Section 6.3 is on square root functions and inequalities. Square root function, the parent function of the square root function, is basically f of x equals the square root of x. And it looks like this. Pick some points here. I picked points because I'm plugging in numbers for x. I chose numbers that were perfect squares to put in there. So I have the ordered pair 0, 0, 1, 1, 4, 2, because the square root of 4 is 2, and 9, 3. You'll notice that its domain is x is greater than 0 and its range is y is greater than or equal to 0 in both cases, for both the domain and the range. And you'll notice that x has to be greater than or equal to 0 because I cannot have a negative number under there. Just can't graph an imaginary number on the coordinate plane. So x has to be a positive number or 0. So here are some transformations on the parent function. So if the basic parent function is the square root of x, then we can have an a out front, as we saw with a quadratic function. We can have a minus h kind of within the function itself, and then a plus k outside here. So the basic transformations would be f of x equals a times the square root of x minus h plus k. It has I call it a vertex at the point hk. It's not really, I don't think they officially use the term vertex, but that's the starting point. That's where the graph begins and takes off and heads off in only one direction. So if h is a positive number, the parent function is shifted to the right. If h is a negative number, it's shifted to the left. And remember, that's a little weird because it's a minus inside here. So if you saw like a plus in here, that would actually be a shift to the left, because that would be x minus a negative number. If k is positive, it's shifted up. K is negative, it's shifted down. If a is a negative number, it's flipped over the x-axis. And if the absolute value of a is greater than 1, it's stretched vertically. In other words, it's wider. If the absolute value of a is a fraction between 0 and 1, it's compressed vertically. That is, it's narrower. So to find the domain of a square root function, we're going to make the radicand greater than or equal to 0 and solve for x. And then to find the range, we're going to plug that value that we found up above in and solve for f of x. So here's a little drawing I did. It looks a little confusing at first, but just to kind of show what some of the transformations look like. Here in black I have the basic parent function, f of x equals the square root of x. Now if you do a number underneath, so this g of x in pink here would be the square root of x minus a negative 4. That's going to translate it 4 to the left. The blue one, h of x, square root of x minus 3, that minus 3 is your plus k on the end, so that actually moves the graph down and you get this blue line right here. G of x has a negative 2 in front of the square root of x, so the negative is going to make it flipped, so it's going to be below the x-axis, and the 2, since the absolute value of that number is greater than 1, it's going to be wider, and you'll notice it's a little bit further away from the x-axis than the others are. And m of x has a 1/2 out front, and that makes it narrower here. And let me just repeat, there's only one arrow when you draw one of these. There is not an arrow at this end where it begins. It heads off this way. Do not put an arrow down there, because basically it can't go any further that way because you'd end up with a negative number underneath the square root sign. So let's do a couple examples here and find the domain and range of each function. Here we have f of x equals the square root of x plus 2 and then plus 5. So to find the domain, I'm going to take the radicand, the stuff underneath the radical, and set it equal to, or make it greater than or equal to 0. And the reason for that is this under here has to be 0 or a positive number. It can't be negative. So subtracting 2 from each side, x is greater than or equal to negative 2. And that makes sense, because if x is negative 2, I get a 0. If x is something smaller than negative 2, so let's say negative 3, if I put in negative 3 in here, I'm going to get the square root of negative 1, and I can't have that. Now, when I plug that into there, I'm going to get, so when I do f of negative 2, that has to be greater than or equal to the square root of negative 2 plus 2 plus 5. So f of negative 2 has to be greater than or equal to a positive 5. So my domain is the set of all x such that x is greater than or equal to negative 2. And my range, the set of all y such that y is greater than or equal to 5. Okay, go ahead and box that. Second example here, f of x equals the negative square root of x minus 6 plus 5. So let's take this, the radicand, and make that greater than, that has to be greater than or equal to 0. So x has to be greater than or equal to 6. Now, let's take that value and let's do f of 6, plug that into the original function. Now, normally I would do a greater than or equal to, but because of this negative sign here, I know that the graph of this is going to be below the x-axis, so my y's have to be less than or equal to whatever this value is going to be. So the negative square root of 6 minus 6 plus 5. So that's going to give me x is less than or equal to negative square root of 0. Negative 0 is just 0. F of 6 is less than or equal to 5. So my domain, the set of all x such that x is greater than or equal to 6. And my range, set of all y such that y is less than or equal to 5. And the reason it's less than is the graph of this, is, as I said, is going to be below the x-axis, so my y's are going to be below that value. So let's take a look at a couple graphs. Let's graph each of these functions, and then we have to state the domain and range. So there's actually a couple different ways we could do this. We could start with the parent function and then do the transformations on it, which actually might be kind of interesting. I think maybe I'll do that one this way. So I'm going to start by graphing the parent function, which looks like this. Okay, so that's f of x equals the square root of x. Now, what are the transformations on this function that I have here? I'm going to go ahead and do him in a different color. So since I have an x plus 3 under here, it's going to be shifted to the left 3, because my h is a negative 3, and it's going to be shifted down 4, which means that my vertex, or my starting point, is going to be moved to the left 3 and down 4. So there's my starting point right there. So what I could do is actually just take each point on my parent graph and do the same thing. Go left 3 and down 4, left 3 and down 4, 2, 4, and then go left 3 and down 4. And draw my graph right there. Okay, that's the pink one. The other way you could do it is if you would prefer to make a table of values, you can go ahead and do that. And I'll show you how we can do that. Now, I know from looking at this, h is negative 3 and y is, and k is negative 4, so those are going to be the first values in my table. Now, what I'd like to do is to choose values of x that are going to give me a nice number. In other words, I want to choose values of x that make the radicand a perfect square. So negative 3 is going to make it 0. If I choose negative 2, then my radicand is a 1. So I'll choose negative 2, and when I plug that in, I get negative 3. Now, if I plug in negative 1, I'm going to get the square root of 2. I don't want to do that. If I plug in 0, I get the square root of 3. I don't want that. But if I plug in 1, I get the square root of 4, which is 2. Minus 4 gives me a negative 2. And maybe I'll do one more point here. If I do, then the next point I would want to do is, or the other way to think about this is do it backwards. So when I put in 1, I get a 4. What do I have to put in to get a 9? For that, I'd have to put in a 6, and then that's going to give me a negative 1, and that's enough points. And as you can see, that corresponds to what I graphed here. The domain is going to be the set of all x, and because it's increasing, because it's getting bigger, it's going to be greater than or equal to the x of my vertex, negative 3. And the range, also because it's going up, is going to, y is going to be greater than or equal to the y of my vertex. And there's my domain and range. Let's take a look at another example here. This one's a little more complicated. F of x equals -3 times the square root of x plus 7 plus 9. I already know a couple things about it. Let's go ahead and write up what I know about it. It's going to be flipped over the x-axis because of that negative. It's going to be shifted to the left 7, and that's because my h is a -7. And it's going to be shifted up 9, and that's because my k is a +9. Now this one would be a little hard. Oh, and also because we have a 3, it's going to be a little bit wider because it's a whole number and not a fraction, which actually makes it a little hard to graph using transformation. So I'm going to make a table to do this one. So I'll make my table of values. And actually you can do this on your calculator as well. I know my vertex is going to be -7, 9, and I got that from my h and my k. And so when I put -7 in there, I get a 0. What number do I have to put in there to get a 1? I'm going with perfect squares here. So to get a 1, I'd have to put in a -6. That's going to give me a 6. In order to get a 4 under here, I have to put in a -3, and that's going to give me a 3. In order to get a 9 under here, I'd have to put in a 2, and that gives me 0. And then in order to get a 16 under here, I'd have to put in a 9, and that gives me a -3. Okay, and you're probably wondering how I did those so fast. I actually did them in my calculator. So let's go ahead and graph that. I think I'll do this one in blue. So we have -7. Let's see, 2, 4, 6, 7, 9. -6, 6. No, that's not right. -6, 2, 4, 6. There we go. -3, 3. 2, 0, and 9, -3. And did I do this one right? 2, 4, 6. Yeah, I did. Okay. And then my graph goes like this. And as you can see, it meets the criteria that we looked at when we did our looked at our transformations here. It is flipped. It's below the x. Well, it's kind of, yeah, it's not going up. It's down. It is shifted to the left 7 and up 9, and it is a wider graph. So we can also graph square root inequalities. So in order to do one, we're going to do basically the same thing. We're going to graph the curve, but it's going to be solid or dashed. Solid if it's a greater than or equal to or a less than or equal to. Dashed if it's just a greater than or less than. And then we're going to shade either above or below. Above if it's a greater than, below if it's a less than. And we'll take a look at a couple examples here. So here we have y is less than or equal to -2 times square root of x plus 6. I'm sorry, x minus 6. I'm going to go ahead and make a table here. And I know from looking at this, my vertex or my starting point is going to be the point 6, 0, because h is 6 and k is 0. Plugging in some values, I actually already did some of these. 7, -2. 10 is going to give me a square root of 4 underneath there, which is nice. Gives me a -4. And 15 gives me a -6, and I won't be able to fit 15 in there, but that's okay. Oh, let's identify what we need to do here with this. So this is going to be a solid line, and it's going to be shaded below. So let's graph those points. So 6, oh, and actually, I think I'm going to count by 2's on this one. So I can fit that 15 in there. So 6, 0, so this would be 2, 4, 6, 0. And then 7, -2 would be this point right here. And then 10, -4 would be this point right here. And then 15, so that's 6, 8, 10, 12, 14, 15. -6 would be right here. That's going to be a solid line going like this. And I shade below, so that's going to be this region right in here. Now, don't go any further left than your vertex is. Just shade all of that in there. And that's the square root inequality. And remember what this means is that any point in this region here works in the inequality. Okay, and let's take a look at one last example here. Y is greater than 4 times the square root of x plus 2 minus 3. This is going to be dashed, and I will be shading above. And let's make a table of values. My vertex is going to be at -2, -3, because h is -2, and -3 is my k. And I can do -1 and 1, and 2 and 5, and 7 and 9. And let's graph those points. So -2, -3, -1, 1, 2, 5. This is actually going to be quite wide. And let's see, 2, 4, 6, 7, 9. Okay, and actually that makes sense because of the 4 in front there. So this is dashed. Okay, and I need to shade above, and so that's going to be this area in here, but don't go any further to the left than that because that's as far as it goes. Okay. So in this section we took a look at square root functions, how to find the domain and range, how to graph them, and how to graph square root inequalities.